Hello, welcome to the notes on converting angle measures between radians and degrees. So today what we're going to be doing is converting between radians and degrees. So just like time has different units of measurement such as seconds, hours, months, years, distance has different measures. We have miles, feet, inches, what have you. So do angles. Angles come in two different measurements, radians and degrees. So before we start converting those, I wanted to review with you how to convert something more simplistic that maybe we're used to, such as the first example, days and weeks. Now, if you're in a chemistry class, you're probably a little bit more used to converting. Ooh, sorry about that. So first thing we're going to do is go from 5 days and figure out, well, what would that be if we did weeks? So we do have to figure out our conversion for that, and hopefully you guys all realize that 1 week is the same thing. It's equivalent to 7 days. Now, why did I pick those two? Well, because I see that I'm going between days and weeks. So when I convert this, the way I like to do this is I create a little fraction that I'm going to be multiplying. So if I'm getting rid of days, I'm going to multiply this by a fraction that equals 1. And that fraction that equals 1 is this 1 week and 7 days. So I have to figure out where does each unit go. Because I want days gone, I put days on the bottom. Because I want this in weeks, I will put 1 week on top. So now the conversion is 7 days is the same thing as 1 week. So the second fraction that I wrote in red is just equal to the number 1. I'm not changing it. So now I'm going to cross out days and days. I'm going to do 5 times 1 on the top over 1. If I put this over 1 times 7. So it's 5/7 of a week, aka this is approximately 0.7143 of a week. And that makes sense that it should be less than 1 week because 5 weeks is not a full, or 5 days is not a full week. Next one, we're going to go from feet to inches. So I'm going to figure out what is my conversion between feet and inches. Well, hopefully you guys all know that 1 foot is equivalent to 12 inches. So when I start this, I write my fraction, 7.4 feet, and I'll put that over 1 times, now I have to multiply by a fraction that equals 1. Because I want feet gone, feet go in the bottom, inches stay on top. 12 inches is equal to 1 foot, so this second fraction is just equal to 1. As long as I multiply by 1, I'm not changing it. Using my calculator, I do 7.4 times 12, and sorry, these feet are going to cancel each other out. 7.4 times 12 is going to give me 88.8 inches, and this is just over 1, so it's 88.8 inches. All right, so if you are currently in chemistry, hopefully this sort of converting between different units is more familiar to you, because I know we do it in chemistry. If you haven't taken it yet, you will see that it is going to be a big part of chemistry. All right, so as I mentioned earlier, degrees can be measured, this should say angles. I'm glad I caught that. Angles can be measured in degrees or radians. In a circle, there are 2 pi radians. So a full circle, as we know, is 360 degrees. That is the same thing as 2 pi radians. So 360 degrees is equal to 2 pi radians. Now where that comes from, your teachers can show you if you're very interested. If not, you will just remember that 1 radian is going to equal 180 degrees. So here's the conversion. 180 degrees is equal to 1 pi radians. And I don't write the 1 because if it's just multiplying it, it's unnecessary. It's just an invisible 1 that is there. Right? So that's our conversion. Just like we used a week equals 7 days or 12 inches equals 1 foot. Now we know 180 degrees equals pi radians. All right, so let's jump right into examples of this. So we're going to convert first from from degrees to radians. And the way that I could tell 1, 2, and 3 are in degrees because of that little degree sign. So if I am starting with 300 degrees, I'm going to write that 300 degrees times. Now, because I want degrees gone, remember this is my conversion from up here. 180 degrees equals 1 pi radians. If I want degrees gone, I put degrees on the bottom, pi on top. Now, when I multiply this together, I'm going to get 300 pi over 180 because the degrees cancel each other out. I am no longer in degrees. On my calculator, I am going to press 300 divided by 180. I get 1.666666667. Math bracket, math enter, enter is going to convert this into the most reduced fraction that we can get, and it's going to be 5/3, and then I just throw pi next to it, or I could put pi in the numerator, so I would have 5 pi over 3. And that is the same thing as 300 degrees. This, however, is in radians. Okay, if you don't have a calculator, I would strongly suggest pausing the video and go get one, because many times setting these problems up is not the issue for students. What is an issue is that they don't know how to type this stuff into their calculator, especially when we get to the problems on the back page, because they are pretty calculator intensive. I would run and get one. All right, moving on to number 2. We have 45 degrees that we want to convert to radians. So I know I'm going to multiply this by 1 because I want to get rid of degrees. Degrees go on the bottom, pi goes on top. I multiply straight across. Okay, if I put this over 1, I could have put this one over 1 as well. 45 pi over 180. Take your calculator. Do 45 divided by 180. It says 0.25. 0.25 is the same thing as 1/4. So you could write 1/4 pi, or realize this is the same exact thing as pi over 4. Either of these answers is the same. All right, last one, 150 degrees times, if I want degrees gone, I put 180 degrees on the bottom, I put pi on top. Using my calculator, I multiply, well actually at this point I don't have to use a calculator, but I would get 150 over 180. Now use a calculator. Do 150 divided by 180. When you press enter, you get 0.833333333. Math bracket, you get 5 over 6 pi. Okay, so this next section now, instead of going from degrees to radians, we're going to go radians to degrees. And this is exactly the same type of idea. Just like I could go from feet to inches, I could go inches to feet. I just have to be careful of where I put my which unit of the angle. So because I'm starting with radians, this is 4 pi over 5. When I multiply, remember my conversion is 180 degrees equals pi radians. Because I want pi gone, I put pi on the bottom, I put 180 degrees on top. What happens is these pi's cancel each other out. I use my calculator. I do 4 times 180, that's 720 over 5 is going to equal 144 degrees. So if I have 4/5 pi radians, that should be less than 180, because 1 pi radian isn't 180. Okay, so number 5, notice the pi is written off to the side, just like I wrote up top for 1, 2, and 3. Either way, pi could either be in the numerator or on the side. Those two are equivalent. If it was in the denominator, that's a totally different thing. All right, so when I write this, I like to write 8 pi over 3. Because I'm converting, I put pi on the bottom because I want my pi's gone, over 180. Pi cancels with pi. 8 times 180 is 1,440 over 3. This is going to equal 480 degrees. All right, notice number 9. Number 6 is just 9. There's no pi in it. But if it's 9 radians, I still have to multiply by pi over or under 180. So now when I multiply this together, the pi's don't cancel. I'm just going to multiply 9 times 180. I get 1,620 divided by pi. Because pi did not go away, I am physically going to press pi on my calculator. I press 1620 divided by pi is your second exponent, like carrot top button, but it's up there. So when I press that, I get the approximation of the degrees. It's 515.66 degrees. So many times, and actually all the time, when you start off with a number, just radians have no pi in it, your answer will be a decimal, because you are going to have to then press pi, which is a decimal that goes on forever. All right, so the back page here is just going to take arc length and area of a sector, which are problems that we've been doing for the last 2 days. And now, instead of our arc measure being in degrees, it's simply going to be in radians. So the only difference is going to be when you think about that formula that we use, we always divide it by 360 degrees because that is a full circle. The only difference now is this is going to be 2 pi, and then your numerator is going to be in radians, okay, versus degrees, where we had the arc measure in degrees and then over 360, because that's how a full circle is. Now it's over 2 pi. So that is an important piece of information, is that you're always going to divide by 2 pi. That is your constant in these problems. Okay, so I am calculating the circumference of a circle where it pi over 4 arc measures 8 inches. Okay, so the wording is a little bit iffy, but the pi over 4 arc, that is its measure in radians, so that goes in my numerator. Pi over 4 divided by always 2 pi. They told me that the measure of the arc is 8 inches, and then I'm looking for the circumference. So I'm going to put a big capital C in the denominator. If I put 2 pi r, that's okay. I'm just going to have to solve for r and then replug it in. If you have not gotten your calculator at this point, I would strongly suggest going to get it, because from experience, I know that a lot of kids do mess up with their calculator. That is the part that gives them a lot of problems with these specific problems. All right, on the left side, what's going to happen is the pi's cancel each other. They're both in the same fraction. They cancel each other. So I'm going to put a little 1 there as a point of reference, okay, because we're going to have 1/4 on top. It's not like it's just 4. It becomes a 1/4. I cross multiply. I am going to get 1/4 times the circumference equals 16. I'm going to leave the units out until the end. Now, to get C by itself, I would multiply both sides by 4, and C is going to equal 64 inches. All right, so this next example, we're calculating the length of an arc. So that means in my proportion, I don't know the second numerator. It's a 3 pi over 2 arc, so that's its measure in radians. So I put that in the first numerator, divided by 2 pi. The 2 pi is always there when I'm dealing with radians and finding lengths of arcs or areas of sectors. All right, in the denominator, put the circumference. If the diameter is 10, the circumference is 10 pi, because remember, circumference is pi times diameter, or 2 pi r. Okay, so if your measure is given in radians and the radians have pi, 100% of the time, these two are going to cancel, the 2 pi's on the left. Now I cross multiply, I will get 2x equal to 3 halves times 10. Remember, you could use your calculator on this. 3 halves times 10 is going to be 15. Now I do have a pi still there because my circumference had pi in it. I divide both sides by 2, and I get x is equal to 15 over 2. I can't simplify that pi. Or I could have written that as 15 pi over 2, but this is 15 pi over 2 feet. The next example, notice that we're switching it up. We are now talking about areas of sectors. So from our previous 2 sections, you should be okay with that. The only thing that's going to change, on the left side, we still have our angle measures. Full circle versus the piece, and then on the left we're going to have area now instead of circumference. So I'm still going to start off with writing out my proportion. The sector has a central angle, which is 4 pi over 5. This is always going to be over 2 pi. It has a radius of 12. We are looking for the area, so I'll call that x. The area of the circle is pi times r squared. You could write that right away as 144 pi, no problem. As always, the pi's go away, and now I'm going to cross multiply. 2 times x is 2x. This is going to equal, take your calculators, do 4/5 times 144. Again, the 144 comes from the fact that I have 12 squared. That is going to equal 115.2, and then pi comes along for the ride. Divide both sides by 2, and we get our answer. The area of the sector is going to be 57.6 pi inches squared. I would ask your teacher in class tomorrow how they want these answers, because we do have a decimal attached to the pi. Your teachers might not mind. They may say just use a calculator. All right, that brings us to our last problem, number 10. It says calculate the area of a circle with central angle pi over 6 and the sector area is 30. So we will write our proportion again. Equal sign. Pi over 6 is the central angle. Because it's in radians, we put it over 2 pi. This is going to equal 30 inches squared over the area of the circle, so I'll just put a big capital A there. All right, the pi's cancel, but remember that doesn't mean I'm left with 6 in the numerator, I'm left with 1/6. So when I cross multiply, I will get 1/6 area of the circle equals 2 times 30, which is 60. To get A by itself, I'm going to multiply both sides by 6, giving me a final area of the circle of 360 inches squared because it's the same units. Now it should be smaller than the area of a sector because the sector is just a piece of the circle. All right, that's it for today. I hope you enjoyed watching, and we'll see you next time. Bye.